Hey guys, welcome to DevGeek, and today we will see Students and Shoelaces from Codeforces B problem. Now this problem is from junior ICPC training sheet and the solution is in Arabic, so I thought I should do a solution in English too so that everyone could access. Now what the given problem statement is that there are two girls, Anna and Maria, who are in charge of a math club for junior students. And when the club gathers together, some of the students behave badly and they tie with each other with some of the shoelaces. Now each string ties together two students, which states that there are like undirected graph. It's an undirected graph. That means both of these students are tied together. It's not a directed graph. So besides, if the two students are tied, then the lace connects the first student with the second one as well as the second with the first one. As you can see, it confirms that it's an undirected graph. Now to restore the order, that means to untie all of the students, what we need to do is, if a student is tied to exactly one student, that means if a particular node is been joined to a only single node, then Anna can reprimand him. That means she can remove him. She can remove that student. So what we need to do here is, suppose we are given a n and m, that means the number of students, and the joins means number of joins which have been happened with the number of students. So let's take an example for the first test case. Now first here it is given that there are 3 students and 3 shoelaces. That means 3 connections have been made. So test case 1 states that the first student has been tied to the second student, the second student has been tied to third student, and the third student has been tied to first student. Now how are we going to how are we going to reprimand them is by, okay, I will take a pen just a sec. Yeah. So how they can reprimand them is, if the particular student is been tied to only one student, so he cannot tie to 2 students. Now as you can see, the first student has been tied to second student as well as the third student, and the second student has been tied to first and third has been tied to second and first. That means they 3 of them have been tied to 2 more than one students. So Anna cannot reprimand him, so we cannot means untie any of the students. That's why the answer is 0. Now let's take an example for the second test case. Second test case states that the first student has been tied to second has been tied to third, and third has been tied to fourth. Now what Anna does is, the student who has been tied to only particular one student, Anna can reprimand him. That means Anna can untie them. So for example, 1 has been tied to 2. That means only one to only a single student he has been tied to. So what Anna can do is, Anna can remove that student, that is first student she can remove. Now the fourth student has also been tied to only single student, that is 3. So Anna can remove him too, or her. Means Anna can remove that student. Now the remaining are 2 and 3. So after untying them, there is another girl who will take these untied students and she will throw out of the club. So the remaining is now only 2 and 3. So as you can see, now the remaining students are only 2 students are remaining. So that means now here 2 is connected to 3. That means now the second student is connected to the third student, and it's only a single student. It is he or she is not connected to to more than one student. So Anna can also untie them, and now we have the another group which is 2 and 3. So the number of groups which have been formed are 2. As you can see, the 1 and 4 has been untied by which is the first group, and now 2 and 3 has been untied, which is the second group. Now you can see, as you can see, the third example also we can do the similar. First student has been tied to 4, second to 4, 3 to 4, 5 to 4, and 6 to 4. So what Anna can do is, Anna can untie all of the students who have been tied by just one who have been tied to just one student. So all these 1, 2, 3, 5 and 6 are tied to only 4. They are not tied to any other student. So and I can untie them and can remove. So the number of groups which have been formed are 1. So the answer is 1. Now how are we going to solve this problem is what we will do is we will first create a graph of all the nodes and the edges, and we will traverse to the whole graph, and we will check how many means what is the size of the graph. So for example, if we take a test case for 2, so if we form a graph, what will happen is 1 will have adjacent of 2, 2 will have adjacency of 3, and 3 will have adjacency of 4, 4 will have adjacent of 3, and as you can see now 3 and 2 are also connected to each other. So and 2 is connected to 1 too, so we need to form that. Okay, so what we can do is we will traverse to the whole node list, and we will check the size of the each node. So first node is connected to only one student. As you can see, the size of that list is 1, so we remove that particular node. So 1 is connected to, and so we go to 2 and we also remove that 1, and we again check is there any only node which is connected to a single node. As you can see, 4 is connected to single node, so we've also untied them, that is remove this node, and we go into the node of 3 and we remove 4. So now the count that is our final answer is been increased to 1, because the first group which has been formed is 1 and 4. Now we again traverse the whole node list, and we see if there is a graph where still only one means one edge is there, like a student is connected to another student, that is there any single edge still. So as you can see, if we again traverse back the whole array, we can see that 2 and 3 are the single edge, that is there is no double edge. So that is 2 is not connected to any other than 3, so we can again remove that 3, and we go in 3 and we remove this 2 also. So CNT increases to 2 and our whole list gets empty. So as our whole list gets empty, so we will break out of the loop, and we will print the answer of CNT, which is 2. So this is how the whole test case works, and this is our approach, and now we will see the code. Okay, so the code is in C++. What we do is we first take the input. So these are nodes and edges, so that means the students and the laces, and then we get the input. So this is the input section. We, after calculating the now what we need to do is mostly we need to calculate like how many means how many are there with the only one edge, right? So we start with the flag, and we check if there is any one size array, means one size node list. So node list with one size, and if we found any one size node list, we set our flag to 1 and we push back that node, and we also clear that adjacency list, because after we found a single edge node, we will clear that node and we will move forward. So here if there is no edge, that means if there is no single edge provided list, that means all of them are connected to more than one students, then we will break out of the loop. This is our breakpoint. That is if all of them are connected to more than one students. Okay, so after that okay, so now what we will do is we will traverse the whole d size vector, that is the ones which are having the 1 as a node. So as you can see, 1 is connected to 2 and 4 is connected to 3. That is, they are only connected to the single strand. So we will traverse that vector. So that is 1 and 4. So we go into the and then we go into the whole again adjacency list, that is our whole node list, and we will check if there is any with the 1 and 4. So as you can see, we traverse and we check that 2 is connected to 1, so we will erase that 1, and then 3 is connected to 4, so we will erase 4. So, and that's how the whole code runs. That means it will run, the whole loop will run until we found that flag is equal to 0. That means until we break out of the loop, that is if there are more than one, if all of the nodes are connected to more than one students, at that point we will break out of the loop. So until that point, whole code will run and we will increase our count, and then at last we will display our count. So that's how this problem states, and this is a very good problem actually for beginners who are just starting to the graph theory, and I would recommend to solve this problem actually. So make sure if you like it, so hit like, share and subscribe guys. Cheers.